and so we were talking about different ways of specifying your operand, and that's called addressing mode. And I mentioned immediate. Remember immediate? That is a constant value or literal value. So like move a comma pound sign 17h. Now 17h is a literal value, but in assembly it's called immediate. Why is it called immediate? Well, it has to do with the way the processor works. Because when you execute instruction, you fetch either whole instruction at a time or a byte at a time or whichever. And so this is saying, well, where can I find the operand? Well, it immediately follows the opcode. Okay, so it's right after the opcode. That's where the term immediate comes from. Okay, so now, so if you see something like move a pound sign 17h, 17h, the pound sign 17h, that's immediate. But if you don't put the pound sign and just put 17 or 17h, whichever, right? Now, what does that refer to? The 17 or 17h without the pound sign. Well, that actually refers to the IData address. Okay? That does not mean the value 17. It means address 17. Okay? So that's that 256 possible bytes is the at location 17. So what does move a comma 17 mean? Well, it means like that C statement. Right? I mean, everybody has C programming, right? So you know it's to typecast 17 as a char pointer and then dereference it, right? So make 17 a char star and then dereference it. That means to load from that location, okay, and then put it into the accumulator. So that's what move a comma 17 means. Okay, so that's a big difference because one puts the value 17 into A, the other puts the value at location 17 into A. Okay, so just one little symbol difference can make a big difference. Okay, so be careful when you. I mean, assembler will accept both, but the meaning is entirely different. Now, there's also what's called register mode, and that allows you to specify like move a comma r1, right, instead of 17. So r1, r2, r3, right? These are registers. Okay, so so you see at least three addressing modes here: register mode, immediate mode, and direct mode. And we'll see direct mode over and over again. So addressing mode is, again, a way of specifying where the operand is. Now, operand could be register, could be immediate. So immediate is part of instruction. Now, if it's in data memory, we show you the direct addressing, but there's also indirect addressing and index addressing. So these have to do with using a pointer, right, as opposed to just specifying the address directly. In a register, or sometimes it could be a bit inside a register. That's called bit addressing. Okay, and so now let's look at registers again. 8-bit registers include the R0 through R7, sometimes called CPU registers, and then special function registers. They include A is one. Actually, as a special function register, it should be called ACC or accumulator. B, PSW, SP, the I/O ports P0, P1, P2, P3, and all those. And when we talk about general purpose I/O, we'll take a look at that. The P0, P1, P2, P3, the general purpose I/O ports. Now there's DPTR and DPHDPL. They're also they're also special function registers. Now DPTR itself I wouldn't call it an SFR because it cannot really be named using any particular address. but its individual components can be. PC for program counter, that is 16-bit register, but again, it cannot be named directly. Now, but I mentioned also, like, the term register is overloaded. So when you talk about addressing mode, register addressing actually refers only to the CPU register, or R0 through R7. Okay. Now, SFR ones, if you want to access like PSW or B or a stack pointer and all those special function registers, you don't use register addressing. You use what's called direct addressing. In other words, those special function registers, each one has an IData location. So what you do is you actually provide the IData address. So for example, port P0 is at hex 80. So you say 80 as the way to specify the special function register. Okay, so now let's take an even lower level look at what it actually looks like. So on the right, you see assembly. And in the center column and then left column, you see binary and hex, respectively. So the binary or hex is really what machine actually gets. The machine doesn't get the text. The text part, the assembly, that's really for human programmer to work with. Okay, and an assembler will translate the assembly to binary. So now, how would that work? So if you have a move a comma R0, well, that actually gets translated to just a byte, and that byte looks like this, right? 1110 1000. And then if you move a comma R7, what do you get? Well, it's 1110 1111. So you say, aha, I know how this works. So the move a comma some register is represented by the first 5 bits, right? Because that's what they have in common. So that's the 11101. And then the last 3 bits are for your register code, right? Because R0 through R7 takes 3 bits to represent. So as you can see, the last 3 digits of that binary, that's 000, correspond to R0. And last 3 digits of the binary for the second one, that's 111, right? That's 7. Okay? So it packs things very tightly like that. Now, if you have move R0 comma A, well, that looks like 1111 1000. And then move R7 comma A looks like 1111 1111. Say, aha, I know how this works. So, so again, right? The move a register comma A, that's the first 5 bits. That's the 11111. And the register R0 or R7, that's the last 3 digits. Okay? So it packs things very tightly. So in the first 4 lines, well, those are really just single byte instructions, right? Even though they look like, wow, move a comma something. It's very tight encoding. This also shows you that A, the accumulator A, it's what's called implicitly addressed, whereas the register, that's explicitly addressed. Because nowhere can you find some representation for A inside the 11101 or 11111. You can't find it. That's hardwired in. Okay. Now, immediate addressing, as I mentioned, it comes immediately after the opcode. So let's take a look, right? So if you have move a comma pound sign 25, well, where is that 25? Well, it follows immediately after your opcode. So the opcode for move A, that's the 0111 0100. And then 25 is that green part underlined, right? So that's a 0010 0101, right? That's 25. Okay, so again, in all cases, you have move something, comma, then the literal. Move something, comma, literal. Could be A, could be register, could be something. These are 2-byte instructions where the immediate is the second byte of the 2-byte sequence. Okay? So now in the first case, A is just hardwired in. In the second and third cases, the R0 or R7, they are part of the last 3 bits of the first byte. And then the 25 is in the next byte. Right? So that's why it's called immediate addressing, because it follows immediately after your opcode part. Okay, so that's immediate addressing. Now, immediate addressing doesn't have to be a single byte. Sometimes, like if you do a DPTR, it could take immediate addressing. That's actually 2 bytes of immediate value. Right. So here's an example. Right? Move DPTR comma and then pound sign 2550 hex. The way it's encoded is hex 90, which is 1 byte, right? And then the 2550 hex, right? So that's the hex 25 and hex 50. So together, it takes 3 bytes in a sequence. But the idea of immediate still applies because the hex 2550 follows immediately after the 90 part, which is the opcode. Okay, and now the assembler will check the range because the move DPTR has room for only a 16-bit immediate, right, or 2 bytes. Now, if you specify something really large, 68975, that's already larger than the largest 16-bit value possible. In that case, it's an overflow, and the assembler will tell you, sorry, it's an error, try again.